Hello everyone. Today we'll be solving a typical projectile motion problem. This specific problem has been taken from Physics for Scientists and Engineers by Survey, and it is chapter 5 from the ninth edition. You can also find it in the 6th, 7th, and 8th editions as well. In this problem we are told that a basketball player throws a ball with an initial speed of v0, making a 40 degrees angle with the horizontal. The distance of from the player to the basket is given 10 meters. We are told also that the basketball player is 2 meters tall and the basket is 3.05 meters from the ground. Okay, let's recap our given. The height of the player is 2 meters. We are also going to assume that the initial height of the ball is 2 meters. So we are going to assume that the player throws the ball from 2 meters above the ground. And the height of the basket is 3.05 meters. The horizontal distance from the player to the basket is 10 meters. And the ball is thrown at a 40 degrees angle with the horizontal, as you can see here. You see 40 degrees angle. And that's your v0 velocity vector. Okay, let's take a look at the question here. We are told to find that initial speed. At what initial speed must the player throw the ball so it goes through the hoop without striking the backboard? So we want to find v0, so the ball hits the basket, enters the basket without hitting this backboard here. And let's take a look at the equations we're going to use. So we have two main equations of motion, one in the x direction, which is x final is equal to v0 xt plus x initial, and y final is equal to 1/2 of at square plus v0 yt plus y initial. Yeah, this is the next step is to choose a datum, and this is really important. If you do not choose the right datum, which means you do not have a reference line to find your heights or distances. For this problem, I chose my reference point at the ground, and I chose the my x and y coordinate are as shown in the picture. So this is the x, the red x and y coordinate, and my origin is at the ball, in the ground, but in the same height as the ball. So my 0, 0 origin is on the ground at the player's initial position. Okay. Now you notice that both equation 1 and 2 have v0x and v0y. And we need to find v0x and v0y because we are only given the resultant being v0, which is the resultant vector. So we need to break that v0 into v0x and v0y. So let's take a look at how we're going to do that. The next page right here. So how do we find v0x and v0y? It's basic trigonometry. So we have your x and y coordinate right here, and we have the v0 vector in between at a 40 degrees angle from the x-axis, which is our horizontal distance. Now we break down the vector v0 into the x-axis, which is this horizontal vector right here, v0x, and we break down v0 into v0y, which is this vertical vector right here. So now we have a right angle triangle with the 40 degrees angle that we can use to solve for v0x and v0y. Now let's start by v0x. We know that v0x is the adjacent side to the angle, so we use cosine. Cosine 40 is equal to the adjacent side, which is v0x, over the hypotenuse, which is v0, which gives us v0x is equal to v0 cosine 40. We do the same thing for v0y. Now since v0y vector is the opposite side of the 40 degrees angle, we use sine. So sine 40 is opposite side of a hypotenuse, so v0y over v0, which gives us v0y is equal to v0 sine 40. Now we plug all our knowns into equation 1 and 2. I've rewritten equation 1 here. Now equation 1 is x final is equal to v0 xt plus x initial. So what is x final and what is x initial? Let's go back to the picture here, the drawing. So this is the original position of the player at the ground. Now from the original position in the x direction, his original position is x initial is equal to 0, because that is where I chose my datum. So the ball is at the x initial equals 0 position, and when the ball enters the basket, it has traveled 10 meters, so its final distance in the x direction is 10 meters. So our x final is 10 meters and our x initial is 0. So we go back to our equation 1 and we plug in our known values. So this equation becomes so x final is equal to 10 equals to v0 cosine 40. Remember that v0x is v0 cosine 40 from earlier times the time plus 0 being x initial. We end up with equation 3. Now let's take a look at equation 2. This is equation 2 here. Now in equation 2 we also need to we're plugging in our known values. Now let's take a look again at the picture here. A is the acceleration. Now the only acceleration here is the gravity in the y direction, which is negative g. Now why it is negative g, let's go back to the picture. Now if you take a look here in the let me draw the g direction here. You know what, that's yeah, I don't need to draw it. That's yeah, there's a shape right here. Okay, so we have our acceleration of gravity right here. It's always pointing down. Gravity always points down, and since our positive y axis is pointing up, g is pointing down, so it is pointing in the negative y direction. That is why in this equation we replace a by negative g. Now let's take a look at the initial and final position in the y direction of the ball. Now the initial position of the ball was at 2 meters from the ground. Now remember our 0 point is at the ground, so and the ball was at 2 meters before it was thrown initially. So its y initial is 2 meters, and when it enters the basket, its final height is 3.05 meters, because that is the height of the basket. Now we are going to replace those or plug in those numbers in equation 2. So we have y final is equal to 3.05 is equal to 1/2 of negative g times t squared plus v0 sine 40. V0 sine 40 again is v0y, which we found earlier, times t plus the y initial, which is 2 meters, and we end up with equation 4 here. Now from equation 3 and 4 we now have two unknowns with two equations. Those unknowns are v0 and time. We are looking for v0, but we do not know time. What we can do is use equation 3 here. Take a look at equation 3 right here. Now after we use equation 3 and we find an expression for the time. If you do that, we get t is equal to 10 over v0 cosine 40. That is equation 5. And we use equation 5, the expression of time, and we plug that into equation 2 here. Equation 4, sorry. This is equation 4, so we got an expression for t uh, and we plug that expression into this equation. After we plug the expression of time into 4, this is, we have to work the algebra, and this is what you end up with, equation 6. Now equation 6 has only v0 as unknown, which is what we are looking for. After we work that equation, we end up with v0 is equal to negative 50g over 1.05 minus 10 tangent of 40, whole thing multiplied by cosine square of 40, the whole thing square root. Now we're taking g as 9.81. The problem did not specify what number to take, but 9.81 is the most commonly used. Some textbook might use 10 meters per second square for the gravity. For this problem, we'll be using 9.81. It won't be affecting the answer that much. We end up with v0 initial equals to 10.67 meters per second. So he needs to throw the ball with this initial speed for it to go through the hoop. Now let's go back to the equation 4 here. After we plug in t, remember t squared is right here. This is t squared, and there is t. That v0 here cancels with this v0, and that sine 40 over cosine 40, that is tangent 40. So in case any of you were wondering where this came from, that is where it came from. Those v0 and v0 cancel out, and then the rest is just algebra to figure out what is v0. I hope you enjoyed this tutorial. I will see you next time for another tutorial on a more complex projectile motion problem. Thank you.